To accurately calculate voltage drop, understanding the K constant is essential. The K constant represents the direct current resistance for a specific conductor material, temperature, and unit length. For copper conductors operating at 75 degrees Celsius, the K constant is 10.74. This value is used in the voltage drop formula to determine the voltage drop per unit length of the conductor. It accounts for the inherent resistance of copper at that temperature. For aluminum conductors operating at 75 degrees Celsius, the K constant is 20.23. Notice that the K constant for aluminum is higher than that of copper. This indicates that aluminum has a higher resistance compared to copper for the same conductor size and temperature. It is important to use the correct K constant based on the conductor material being used in the circuit. To use these K constants in a voltage drop calculation, you will also need to know the current flowing through the conductor, the length of the conductor, and the circular mil area of the conductor. The voltage drop can then be calculated using the formula 2 times K times I times L divided by circular mils, whereas the current in amps, L is the length of the conductor in feet, and circular mils is the cross-sectional area of the conductor in circular mils. The result is the voltage drop in volts. Always refer to the National Electrical Code or NEC for the most accurate and up-to-date K values and voltage drop calculation methods. NEC Article 210.19. 8.1. Informational note number 4 outlines an example of how to calculate voltage drop. Using the constants 10.74 for copper and 20.23 for aluminum enables calculation of the estimated voltage drop in a circuit. Maintaining voltage drop within acceptable limits, typically 3% for branch circuits and 5% for feeders, is crucial for ensuring proper equipment operation and preventing premature failure. The National Electrical Code recommends a maximum voltage drop of 3% in branch circuits and 5% in total, which includes both feeder and branch circuit. Excessive voltage drop can lead to reduced light output from lighting fixtures, decreased motor performance, and malfunction of electronic equipment. Voltage drop is impacted by several factors. Firstly, conductor material. Copper and aluminum have different resistivities, which directly affects the voltage drop. Copper has a lower resistivity than aluminum, meaning that for the same conductor size, copper will have a lower voltage drop. Secondly, conductor length. The longer the conductor, the greater the voltage drop. This is because the resistance of the conductor increases proportionally with its length. Thirdly, current. The higher the current flowing through the conductor, the greater the voltage drop. This is because the voltage drop is directly proportional to the current. Fourthly, conductor size. The larger the conductor size, the lower the voltage drop. This is because the resistance of the conductor decreases as its cross-sectional area increases. Fifthly, temperature. The resistance of a conductor increases with temperature. Therefore, the voltage drop will also increase with temperature. To minimize voltage drop, you can take several measures. Firstly, use larger conductor sizes. Increasing the conductor size reduces the resistance and therefore the voltage drop. Secondly, shorten conductor lengths. Reducing the length of the conductor reduces the resistance and therefore the voltage drop. Thirdly, reduce the current. Reducing the current flowing through the conductor reduces the voltage drop. Fourthly, use copper conductors. Copper has a lower resistivity than aluminum, so using copper conductors will reduce the voltage drop. Fifthly, maintain proper temperature. Keeping the conductor temperature within its rated limits will help to minimize voltage drop. In practice, voltage drop calculations are essential for electrical design and installations. Ensuring that voltage drop is within acceptable limits is critical for the safe and efficient operation of electrical equipment. When performing voltage drop calculations, it is important to consider all of the relevant factors, including conductor material, conductor length, current, conductor size, and temperature. It is also important to use the correct K constant for the conductor material and temperature being used. The K constant is a temperature-corrected constant that represents the ohms per circular mil foot of a conductor at a specific temperature. The K constant is used in the voltage drop formula to determine the voltage drop per unit length of the conductor. The voltage drop formula is voltage drop equals 2 times K times I times D divided by circular mils, where K is the K constant, I is the current in amps, D is the one-way distance in feet, and circular mils is the conductor area in circular mils. The result of this equation is the voltage drop. By understanding and applying these principles, you can effectively manage voltage drop and ensure the reliability of electrical systems. Let's go over some examples. A 120 volts 20 amp circuit uses number 12 American wire gauge or AWG copper conductors with a one-way run of 75 feet. What is the voltage drop? Number 12 AWG copper has a circular mil area of 6,530 circular mils. The K constant for copper at 75 degrees Celsius is 10.74. Voltage drop equals 2 times 10.74 times 20 times 75 divided by 6,530. The result is a voltage drop of 4.93 volts. 4.93 volts divided by 120 volts times 100% equals a voltage drop of 4.11%. This exceeds the recommended voltage drop of 3% for branch circuits. To solve this, you could increase the conductor size to number 10 AWG copper, which has a circular mil area of 10,380 circular mils. Voltage drop equals 2 times 10.74 times 20 times 75 divided by 10,380. The result is a voltage drop of 3.10 volts. 3.10 volts divided by 120 volts times 100% equals a voltage drop of 2.58%. This is within the recommended voltage drop of 3% for branch circuits. Another example. A 240 volts 30 amp circuit uses number 10 American wire gauge or AWG aluminum conductors with a one-way run of 100 feet. What is the voltage drop? Number 10 AWG aluminum has a circular mil area of 6,530 circular mils. The K constant for aluminum at 75 degrees Celsius is 20.23. Voltage drop equals 2 times 20.23 times 30 times 100 divided by 6,530. The result is a voltage drop of 18.57 volts. 18.57 volts divided by 240 volts times 100% equals a voltage drop of 7.74%. This exceeds the recommended voltage drop of 3% for branch circuits and 5% for feeders. To solve this, you could increase the conductor size to number 6 AWG aluminum, which has a circular mil area of 26,240 circular mils. Voltage drop equals 2 times 20.23 times 30 times 100 divided by 26,240. The result is a voltage drop of 4.63 volts. 4.63 volts divided by 240 volts times 100% equals a voltage drop of 1.93%. This is within the recommended voltage drop of 3% for branch circuits and 5% for feeders. The K constant values for copper and aluminum at 75 degrees Celsius are essential for accurate voltage drop calculations. Copper has a value of 10.74 and aluminum has a value of 20.23. Remember to always consult the NEC for the most up-to-date information and guidance on voltage drop calculations.